And my topic today is treatment algorithm for ventral hernia. Is artificial intelligence needed to achieve it? Now, let us try to understand what artificial intelligence is, because we as doctors are not really conversant with these things. So any intelligence that is outside humans and animals is artificial intelligence. So basically, intelligence demonstrated by machines is AI. And AI research is a field of study of intelligent agents which refer to any systems that perceives its environment and takes action to maximize its chance of achieving its goals. Supposing you have a glucometer in your hand, it takes the blood and then gives a report. So something, a hardware is always called a smart substance or a smart material. But when it is a software, it is usually called artificial intelligence. The other term that we always have been hearing is machine learning. Machine learning is a field of inquiry devoted to understanding and building methods that learn, that is methods that leverage data to improve performance on some sets of tasks. And this is a part of artificial intelligence. So machine learning again has 4 different parts to it. I'll explain each one of them. First is supervised learning, which includes a set of data that contains both inputs and desired outputs. And these inputs and outputs have to be fed into the model. So supposing you want to buy a house, the data of the house, particular size, actual prices of different materials that go into building a house should always put into the algorithm. And then you compare the different builders who are offering apartments in this Jaipur, and this can be done by this supervised learning. Similarly, if you want to go to a stock market and buy some stocks, you have a lot of variables, and all this will be analyzed and you will be told where you get your return of investment. Now, let's move to unsupervised learning. It is a set of data that contains only inputs and therefore learn from data that has not been labeled, classified or categorized. So for example, daily morning we get up, take a phone and look at Google News. This Google News takes up stories from the web. It selects what is being watched and heard by people and it offers to you. So similarly, if you have a huge population and you know their DNA microarray data and you feed all this data, this artificial intelligence can actually categorize them based on their genetic distribution and show who are similar in genetic patterns. Now, the third type is called reinforced learning. A computer program interacts with a dynamic environment in which you must perform a certain goal. This, all of you know about the Tesla car. So you have a dynamic environment in which the Tesla car is driven using artificial intelligence, and this is reinforced learning. Now, the fourth type is called recommender systems. Recommender systems can be defined as a learning technique by virtue of which online user can customize their sites to meet customers' tastes. For example, you have reviews, Google reviews. You see that and then decide what you want. You can take your own phone and this is a pen kept on a table. I take a photo and put it on Google Lens, and the Google Lens will analyze and tell me where all these products are available. And similar products, what is its name, who is selling for whom. So that way I really know where to buy it from. So machine learning is today being used by us in our life in so many various things, including a whole lot of diagnostics and medical fields. And it is high time that we get involved into developing newer things for our own use. The next is computer vision. So computer vision is an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images and videos. So if you put a photo into the computer will try to analyze all the different things that are there in the photo and understand what is contained in the photo. And that is computer vision. And we have already started using computer vision. So this we can use for radiology diagnosis, for pathology diagnosis. So we have a slide, and the slide we put it in with into a software having artificial intelligence. It will give us the diagnosis. We have reached up to 90% accuracy, but still there is a lot of work to be done to be more accurate. Now, this is a junior colleague of mine in Bangalore, who is Anand Vinekar, who's done tremendous work. He's worked on retinopathy of prematurity. They take, health workers take photographs of the retina of all newborns throughout Karnataka state, and all that is fed to them. And they use this, some algorithms in artificial intelligence, and then they look at who can go into progressive retinopathy. And these babies are called to the hospital and treated to prevent blindness. And this is a huge social work that is being done. Now, what about ventral hernia? Ventral hernia, we have a huge amount of variables, a whole lot of variables. It's not as simple as inguinal hernia, where we say tap or tap and both are same. So the type of repairs are there. A lot of different types of meshes are there. There are a lot of ways in which we can fix and how many fixations we can do. The plane in which we want to fix the mesh also differs. And there are a whole lot of techniques. I've just put a few examples for people to learn what can be done. And we have a whole lot of ways to augment the effect and give us a better patient to perform surgery. So what can computer vision do to our CT images? It can calculate the CT, the loss of domain. It can calculate the visual measurements of what is inside the abdomen and outside the abdomen, size of the defect, condition of the abdominal wall, and many other things can be informed to us by computer vision in the computer. So to conclude, what I would like to say is ventral hernia management can be complex. There is no standardization as yet, and artificial intelligence can help us with the algorithms that guide us in decision making. Creation of a ventral hernia registry is the first step towards the goal, and I'm extremely happy that in the next few weeks we are starting the hernia registry, and all of us will start collecting our data, and this will make a major difference and make this dream a reality. So what is the work in front of us today? Today we have to identify all the parameters that we need to capture. So when we are making the registry, it's extremely important. People making the registry should capture every detail that needs to be captured, and this has to be standardized. So all the variables have to be standardized, and all this data has to be given to engineers, and engineers will build a solution or a model or algorithm. And so we finally have this by interfacing surgeons' knowledge and engineers' expertise. And once we have this algorithm, we start using it on our daily practice, and we have to validate the system, whether it is giving us the accurate information and advice and suggestions. So every time there is some new technology, new procedure, new product, then there has to be a continuing refinement of this algorithm. And this is going to be a continuous process, but this will make it much more accurate than the practice that we are following today in our daily lives. So I would like to go back to what our president said. What would you do is what everybody is asking. But from there, what should I do will be an answer given to us by this artificial intelligence. Thank you for a patient hearing.